Hello and welcome back to my pre-calculus enrichment series. We are on episode 3 now, going to talk about rational functions. I have an example below. We have this graph here. You probably have seen this in Math 3 before, but in this video I'm just going to kind of review some key features of rational functions, specifically with their graphs, and the next video will deal more with algebra. Okay. Before I teach you about some key features though, it would be good for me to find out what you already know. So it's time to play What's That Feature? I'm your host, Sage Cooley. And so kind of what I want you to do here is I have a graph on the left and have a word bank on the right. And so I want you to try to match up the numbers with the letters. So for example, you might have 1A, 2B, 3C. I didn't make it that easy, but that's just an example. So pause the video if you need to and go ahead and try this. It looks like we've narrowed everything down to concavity. If you have watched my previous videos, I do talk about, what concavity is, but for this episode, we're going to focus on determining concavity, not algebraically, graphically. And I think once you're in calculus, you'll learn more about concavity algebraically. But so let me give you kind of a phrase that'll help you remember. Concave up is like a cup, concave down is like a frown. And so that's just like a really easy way to remember what it looks like. So letter E over here, anyway, is looking like a cup. So I'm going to put my E next to number 5. And then obviously F has to be concave down, but you can see that it's kind of like a frown, or if you don't like the rhyming, you could say it's like a hill, whatever you prefer. Okay. And so I just have a few key features up here that I want to go through. So taking a look at continuity, so we're looking if we can find any holes in this graph. I don't see any labeled for me, so it looks like we're not going to have any of those. That's supposed to say NA, that kind of looks like an H. Asymptotes, okay. So we just sort of went over that, but I'll kind of talk about it again. When we're looking at asymptotes, there are kind of two main ones you want to remember. We have vertical asymptotes, so that's like sort of an x equals equation, just this one vertical x value, the graph goes kind of crazy around. And then we have the same thing, but we also have a horizontal one, and that is a y equals equation. So anyway, let's start out with vertical asymptotes. That's weird that I wrote it that way. That's a little better. Okay, vertical asymptotes. So I want to look on my graph and see if I can find that imaginary vertical line. And it looks like right here at x equals 4, my lines are not straight, but I'm trying. That's good enough. So this is the line x equals 4, and we can definitely see the graph approaches that value. So vertical asymptote, x equals 4. Horizontal asymptote, again, we're looking for the same thing, but it's going to be horizontal this time. It's a y value. And so I can kind of see where my graph is flattening out, where it's approaching something. So I want to see where it gets really close to. And I can see that the graph is kind of approaching this line right here. Yeah, so now I want to see where that is. That looks like it is at the y value 2. So y equals 2 is my horizontal asymptote. The next thing is intercepts. We have two different kinds of intercepts. We have an x-intercept and a y-intercept. And so if we look on here, we can see that the graph crosses the x-axis at that red point right there. And then it crosses at that y value right there. So they're pretty close to each other. And then we want to look at domain. So something very important to keep in mind about domain is that it's affected by holes and it's affected by asymptotes, vertical asymptotes to be specific. So we want to see, before we even get into domain, we want to know what our holes are, we want to know what our asymptotes are. And so that's why I put it in this order. And we didn't have any holes, but we did have a vertical asymptote at x equals 4. So we're going to kind of write it as normal in interval notation. But now I have to break my interval at x equals 4. 4 is not included, but we're going to have a union and from 4 to infinity. Okay, that's our domain. And then remember how we talked about our range is what happens when we actually apply our domain. So we have removed holes if there were any, we've removed asymptotes. So really at this point, anything that's going to affect our range is going to be our horizontal asymptote. It's the kind of thing that restricting our domain is not going to fix. Our horizontal asymptote is at y equals 2. And so we want to write this in where we're going from negative infinity to 2, union 2 to infinity. And if you want to look at this graphically, you can see how our y values do approach negative and positive infinity, but right at that y equals 2, we don't have a value. And I have one more example for you where we're going to be looking at some additional key features. These are the ones that I haven't covered so far. So one thing that you might be asked to do is find where the graph is positive. And graphically, you can kind of see where that's occurring. We can see that one branch of this graph is below the x-axis and one of them is above the x-axis. So if we start out with positive, it looks like from 4 to infinity, our graph is above the x-axis. Well, where is it negative? Just wherever it's not positive, which is going to be from negative infinity to 4. 4 is not included. It's not in our domain. We don't like x equals 4. Okay. Increasing, decreasing concavity. Those things might be new to you. Something that I emphasize when I talk about them is left to right. And you'll see why I do that in a minute. So if I'm looking at where the graph is increasing, I'm just going to kind of check both of my branches and I'm going to see what my slopes are doing. Increasing and decreasing refers to slopes. So I kind of like to draw my tangent lines like this, because it's kind of hard to see the sign of your slope when it's a curve. So it's easier to just kind of draw it like this. And we can see that my lines are kind of negative lines and they're getting even more and more negative. So if my slopes are negative on that branch, then my slopes are decreasing, or my function is decreasing, sorry. Let's look at the other branch. Again, moving from left to right, very important. So super, super negative slopes, almost vertical. And then they're kind of flattening out and becoming more positive, but they're still negative. So we can see that this graph is always decreasing. And so we are not increasing anywhere, decreasing from negative infinity to 4, union 4 to infinity. I don't want to include my 4 anywhere because it's not a part of the graph. Now let's talk about concavity. So concavity also has to do with increasing or decreasing. We're looking at concavity. The way that I like to think about it is concavity is kind of what my slopes are doing. So if I am concave down, my slopes are getting more and more negative as I go along. So let's look at an example. If you look at the left right here, my slopes are kind of flat, and then, oh no, becoming very negative as I approach x equals 4. And so we can see here that this must be concave down. My slopes are decreasing. Another way to look at it, which is a lot easier, concave down like a frown. How easy is that? So concave down from -infinity to 4. Now, our other kind of concavity is concave up, and one way you might like to think about that is your slopes are becoming more positive. So if I look at the right branch, you can see how my slopes are very negative at first as I'm moving left to right. Then they're kind of flattening out, and it looks like they're wanting to become more positive. So in that case, I would say it's concave up. Easy way to remember it, concave up like a cup. So from 4 to infinity. Finally, we are looking at end behavior. That is what the graph is doing as x goes to the different extremes. So as x approaches infinity, as it gets bigger and bigger and bigger, what are my y values doing? And it looks like if I move along here, my curve is trying to get to 0, but it's not quite reaching 0. So my y value is approaching 0. Now we want to look at the other direction. X goes to -infinity. Again, my y values are doing the same thing. So that is end behavior. Okay, that is it for this video. I appreciate you watching. I hope you come back for the next one.